In this video, we're going to make a series of different pyramids, and you're going to see what I mean in just a second. A few of these won't actually look like pyramids, but it's meant to be a progression so that it's a little easier to get to the last thing. Let's open up the Pyramid A program. You'll see right off the bat, we're given a bunch of constants. Now, let me show you what Pyramid A looks like, what we're going to make. So here is the picture for Pyramid A. You might be looking at this being like, how the heck is this a pyramid? Don't worry about it right now. Let's make sure all of these constants make sense in terms of the picture we're going to draw. Does brick height make sense? It's how tall each one of these bricks are, approximately that distance right there. What about brick width? It's actually that distance here. The gap is the distance between each of the bricks, so that kind of little part here, both horizontally and vertically. Number of rows, there's actually 10 rows of bricks. You might be wondering why there's also not number of columns, and that's because when we eventually start moving forward, we're just going to be basing this on rows. For now, we can assume that the number of rows and number of columns will be the same, so we're going to use this for both. Start X and start Y, that's going to be the XY coordinate of the top left corner. So this isn't all that dissimilar from what we saw in the stacked circles program earlier. If you think about it, I'm doing something over and over again in this program, and what I'm doing over and over again is I'm drawing a full row of bricks. So let's do this. Let's start with a for loop for int I equals 0. I is less than num rows, I plus plus. Now, what would be the code inside here would be the code draw one row. To draw an entire row, don't I also need a for loop? So are we going to need a nested for loop here? Yeah, we totally are. For int j equals 0, j is less than also num rows here, because again, it's the same number of rows and columns, j plus plus. Let's do this. Let's make a new G rect. Let's call it brick equals new G rect. Remember, it's always X, Y, width, and height. Let's think about what determines the X coordinate for these. That's how far horizontally over it is. We know the first one will start at start X. So let's start with start X plus. Now we have to think about how much each brick moves over by. Every time I add a new brick that has a different X coordinate, doesn't it move over by one brick width plus one gap? So there's going to be some sort of brick width plus gap. Now the question is this quantity multiplied by I or J? Well, remember, how are we thinking about I? I controls which row I'm on. When I change rows, I change in the Y direction. But we're doing the X coordinate right now. So I think, shouldn't this have to do with J? J tells me which column I'm on. As I move across the columns, it increases my X coordinate. So I'm going to do J times this. There's my X coordinate. The Y coordinate's going to be similar. The very first one is start Y. Plus, every time I move down one brick, I move down by the distance of one brick height plus one gap. And what controls my movement in the Y direction is I. That's what tells me which row I'm on. So I'm going to multiply this quantity by I. And the width and the height of each of these bricks are pretty straightforward. It's just going to be brick width, brick height. Let's add brick. And actually, probably before that, just to make it look like the picture, let's fill in all of these bricks. So I'm going to do brick.setFilled, true. And it indented a little weirdly, so let me put this back over here. And let's go ahead and run this. I'm going to compile, close out of the picture because hopefully we're about to see that picture on my BlueJ screen. Let's run pyramid A. And there we go. There it is. Again, not all that dissimilar to the stacked circles program we just did. Probably the biggest difference is that I also had to include this gap between the bricks. We've successfully made pyramid A. This looks exactly like the picture that we saw before. Let's take a look at what the difference is between pyramid A and pyramid B. I'm going to close out of this. Let's kind of move our code. Whoa, let's move our code over here. Let's take a picture, look at the picture for pyramid B. And let's compare the difference between pyramids A and B. Here's pyramid A. Now, what do you actually notice about this? It's actually the exact same configuration as before, except that aren't I actually starting with no bricks and increasing by 1 brick every single row? So what's actually the only difference between pyramid A and pyramid B? With pyramid B, the number of bricks in every row corresponds to which row you're actually on. In pyramid A, the number of bricks in every row is always 10. So the code for these is actually going to be very similar. In fact, let's actually highlight everything inside pyramid A, kind of constants all the way down through the end of the run method. Let's copy this and let's go inside pyramid B, and I'm actually just going to paste it right on top of the run method here. Now, if I run this, I should be able to see the same design as pyramid A. I just copied and pasted in my code for pyramid A, but inside pyramid B. Now again, what here controls how many bricks are in each row? Because isn't that the only place where this differs? Isn't the J for loop kind of adding the brick into each row? And this here actually tells me how many bricks are in every single row. Now, how many bricks are in every single row for pyramid B is not actually the same number every single time. It should change as my row changes. Doesn't I actually keep track of which row I'm on? So watch what I'm going to do here. Instead of num rows, I'm going to type I. Let's think about what this does. When I is 0, J starts at 0. Is 0 less than 0? No. So this inner for loop is actually not going to happen. When I is 1, J starts at 0. This for loop will happen once, meaning I'll have 1 brick. When I is 2, this inner for loop will go twice. When I is 3, this inner for loop will go 3 times. And you can see what that pattern is like. On the first row, I'm going to make 0 bricks. So weirdly, there are actually 10 rows here, but the top one actually has no bricks in it. The second row, I'm going to make 1 brick. The third row, I'm going to make 2 bricks, and so on and so on. I ends up being how many bricks I want to be in that row, because that's the same as which row I'm on. Let's compile this, and let's run pyramid B, and we actually will get exactly this picture. Now, pyramid C is where things start to get a little crazy. I'm going to close pyramid A up here. Let's bring pyramid B up here, and let's actually open up pyramid C, which looks like this. Oh my gosh. What's the difference between pyramid B and pyramid C? Well, all the y coordinates of the bricks are the same. The number of bricks in every row is the same. It's actually the x coordinates that are now different here. Specifically, the x coordinates have all been shifted over by a certain amount. I'm going to close out of pyramid B. Let's do the same thing we just did, because aren't these pretty heavily related? Let's go into my pyramid B. Let's copy everything, run method all the way up through the constants, and let's put it on top of here. Oops. There we go. Now if I run this, I'll just see the picture for pyramid B. Like I said, isn't the only difference actually between this one and this one that the bricks in each row are kind of shifted in the x direction? So let's do this. I'm going to make a variable up here representing that shift. Let's do int shift equals, and let's think about how much each one of these is being shifted. If we look at the bottom row here, is the bottom row being shifted at all? No, it's actually not. Every time I go up one, isn't the row actually being shifted by an extra half a block width plus half a gap? So that's going to factor in here somehow. Let's do brick width plus gap divided by 2. We know that that's going to be some part of the shift. Now let's just think about the first row. How much is this very first one shifted over by? Isn't it actually the maximum amount? So let's write this. Isn't it num rows times the brick width plus the gap divided by 2? We have to add this into the x coordinate. So in here, let's make this window a little bit bigger. I'm just going to put plus shift. Now let's compile, let's run this, and let's see what it looks like. Now I've shifted the whole thing over. Which brick here is in the right place? It's actually this one, the very top one here. And which ones aren't? Actually, everything beneath it. Each one of these needs to be shifted over less and less every single time, which means that the maximum amount I'm going to shift it is going to be num rows. But every single time I increase a row, it needs to go back by an extra brick width plus gap divided by 2. How am I going to represent that? Well, like this. You'll notice that this feels very similar to what we did in the bullseye program. If you remember, we had this problem where because my rings were adding smallest to biggest, the circle that was being added was covering the last one behind it. But by actually replacing all of the i's in our program with num rings minus I, we had the opposite behavior. Instead of starting small and counting up, we started big and counted down. And that's the exact same thing we're doing here. Which one actually has the biggest shift is the very first one. So I want to start with the shift being as big as it's possibly going to be. And then as I increases, won't this whole number get smaller? Exactly. So let's compile. And if I run this again, there we go. There is our pyramid C. It's beautiful. Wow. So again, what's the big picture of what's happening here? Every time we add a new row, this shift gets smaller. And that makes sense. The shift is how much it's pushed over in the x direction, and every time I go down a row, that number should be less and less. We had some kind of crazy nested for looping going on here, including this using j and I in the same for loop, but this ended up actually being pretty cool, and hopefully not too crazy to move from pyramid A to B and then finally to pyramid C.